After studying this module, you shall be able to know about the basic concept of structural equation modeling. Learn the steps involved in SEM, understand the limitations and applications of SEM, and know about the popular statistical packages for SEM. The structural equation modeling, or SEM as we call it, is one of the latest statistical procedures that are gaining popularity. The SEM is generalizable and flexible and thus has wide applicability across the different fields of knowledge. The current module proposes to introduce the basic concepts related to SEM, but before the readers proceed with the text, they are advised to refresh their statistical knowledge pool in multiple regression analysis and analysis of variance. One of the fundamental ideas that is taught in intermediate applied statistics courses, the effect of additive and multiplicative transformations on a list of numbers. Students are taught that if you multiply every number in a list by some constant k, you multiply the mean of the numbers by k. Similarly, you multiply the standard deviation by the absolute value of k. This idea generalizes in various ways to several variables interrelated by a group of linear equations. The rules become more complex, the calculations more difficult, but the basic message remains the same. You can test whether variables are interrelated through a set of linear relationships by examining the variances and covariances of the variables. Structural equation modeling is a very general, very powerful multivariate analysis technique that includes specialized versions of a number of other analysis methods as special cases. The technique is basically an elaboration of the general linear modeling procedures and takes advantage of the ANOVA and multiple regression analysis. The structural equation modeling, or SEM, is a multivariate statistical technique that involves both observed variables and latent variables. The technique can be applied to experimental as well as non-experimental research data of longitudinal and cross-sectional research. SEM is a statistical methodology that takes a hypothesis testing or confirmatory approach to the analysis of structural theory pertaining to a phenomenon. SEM allows the researcher to take a confirmatory approach with an established theoretical background. That is, by explaining the relationships among the observed and the latent variables. The SEM does this for a number of multivariate techniques individually or in combination. It involves multiple related structural equations that are solved simultaneously to test the proposed model. SEM is not causal and does not explain the cause and effect relationships between the variables. The SEM focuses on two aspects. The causal relationships in the model are represented by arriving at a series of structural regression equations. And the other aspect is that the structural equations representing the causal relationships can be pictorially presented to facilitate a better understanding of the theoretical concepts under study. There are a number of specialized statistical packages which are readily available for a user-friendly application of SEM to the data. Some of the software packages are Lizrel, Amos and EQS. As the module explores the basic concepts of SEM, the readers are advised to go through the works of authors like Tabachnik and Fidel, Schumacher and Lomax and Byron for a deeper understanding of the SEM and a more elaborate work on it. The concept of SEM. The structural equation modeling, known by various other names such as confirmatory factor analysis, latent variable modeling, causal model, etc. The SEM is a multivariate statistical technique that combines ANOVA, factor analysis and multiple regression and is used to test relationships among the variables. SEM is a graphical modeling interface that uses confirmatory factor analysis to correct measurement error. It tests models with multiple dependent variables and allows for variables to be dependent with some variables and independent with respect to others. The terminology of SEM, independent variables are termed exogenous variables and dependent variables are termed endogenous variables. SEM is used to test the theoretical hypothesis about the causal relationships among the variables. The powerful technique of structural equation modeling is used for measurement purpose to find the relationship of measured variables to the latent factors, as it can test the relationships between observed as well as unobserved or latent variables. Indicating the directionality of the effect, it tells which variables affect others and provides lot of information about the proposed model. Let us explore the differences between the SEM, that is structural equation modeling, and the old multivariate procedures. The table given takes SEM and old multivariate procedures that we have been discussing in other modules of this paper, and the reader must have gone through them, and SEM is compared on different points. First is the SEM takes a confirmatory approach to the data and its analysis, whereas the most of the multivariate procedures that we have studied up till now or are going to study in the subsequent modules have been exploratory in nature with the data analysis. In SEM, the pattern of intervariable relations are specified a priori. The SEM is suitable for inferential analysis, whereas in the multivariate techniques of the older generation, we find that the methods are descriptive by nature, and the example is exploratory factor analysis, whereas we use the confirmatory factor analysis for SEM, and therefore making the hypothesis testing in exploratory or the older multivariate methods as a difficult process to adopt. The SEM provides explicit estimates of error variance and parameters, whereas the older methods, the multivariate methods, are incapable of assessing and correcting the measurement error. The SEM uses both observed and unobserved, that is the latent variables, and uses them for data analysis. In most of the multivariate methods that we have taken up, we find that the data analysis is limited to only the observed measures. In SEM, the methodology has alternative programs to explore relations, interval indirect effects and point estimation, whereas the multivariate methods that we have used have no alternative methods to model multivariate relations, interval indirect effects or point estimation. So we find that SEM, these techniques and procedures are a step ahead of the usual or the older multivariate techniques that we have been adopting up till now. And that is the reason we find that SEM is gaining popularity in the field of statistical analysis and quantitative methods very rapidly. Statisticians have developed procedures for testing whether a set of variances and covariances in a covariance matrix fit a specified structure. The way structural modeling works is as follows. The researcher states the way he believes the variables are interrelated. Often this is done with the help of a path diagram. This is done using the already stated theoretical concepts from the knowledge pool. So before one proceeds with the application of structural equation modeling, it is very important to have a sound knowledge pool of the particular area in which you want to proceed with your research. The next step is that one works out via some complex internal rules what the implications of these are for the variances and covariances of the variables. Then one tests whether the variances and covariances fit this model of them that they have devised using SEM. The results of the statistical testing and also parameter estimates and standard errors for the numerical coefficients in the linear equations are reported. On the basis of this information, then the researcher decides whether the model seems like a good fit to one's data or not. These are some important and very basic logical points to remember about the process that we are just about to explore, called the structural equation modeling. First, although the mathematical machinery required performing structural equation modeling is very complicated, we must keep in mind that it is one of the better measures that has to be applied to the research data. Second is, one must remember that it is unreasonable to expect a structural model to fit properly for a number of reasons. A structural model with linear relations is only an approximation. The world is unlikely to be linear, and indeed the true relations between variables are probably non-linear. Moreover, many of the statistical assumptions are somewhat questionable as well. So, although we have a very good fitting structural model, it is unreasonable to expect that it is a perfect fit. Third, we must remember that simply because a model fits the data, well, it does not mean that the model is necessarily correct. One cannot prove that a model is true. To assert this is a fallacy of affirming the consequent. The definitions of SEM. As defined by eminent scholars, the structural equation modeling SEM is defined as that SEM is a comprehensive statistical approach to testing hypotheses about relations among observed and latent variables. This was proposed by Hoyle in 1995. Another definition says that SEM is a methodology for representing, estimating and testing a theoretical network of mostly linear relations between variables. This definition was given by Rigdon in 1998. McCallum and Austin in 2000 proposed that SEM test hypothesized patterns of directional and non-directional relationships among a set of observed, that is measured, and unobserved, that is the latent variables. These are but some of the few definitions that we have taken up from the number of SEM definitions available and produced them for you. The uses of SEM. Hoyle's 1994 reviews and tells us that SEM can be used to address the following. It questions, it answers and addresses the questions about the causal processes involved. At the same time, SEM can also be used for the basic questions of measurement, and then SEM also addresses the questions about the causal process when variables are not well measured. Let us explore the steps that are involved in the conduction of SEM or the application of SEM to the research data. Steps of conducting SEM. The first step is development of the hypothesis. The first step in conducting SEM is to develop a hypothesis by seeing the relationship that exists among the observed and the latent variables. The next is the construction of a path diagram. The path diagrams are constructed and they pictorially represent a model. Path diagrams play a fundamental role in structural modeling. Path diagrams are like flowcharts. They show variables interconnected with lines that are used to indicate the causal flow. One can think of a path diagram as a device for showing which variables cause changes in other variables. However, path diagrams need not be thought of strictly in this way. They may also be given a narrower and more specific interpretation. Consider the classic linear regression equation y is equal to ax plus e. Any such equation may be represented in a path diagram. And of course, a path diagram may have a number of such linear regression equations that may make the complete path diagram or the model. Such diagrams establish a simple isomorphism. All variables in the equation system are placed in the diagram either in boxes or ovals. Each equation is represented on the diagram as follows. All independent variables, the variables are on the right side of the equation and they have arrows pointing to the dependent variables. The figure is an example of the path diagram as we shall just explore it. The exogenous latent variables are the independent variables as they are responsible for causing changes to other variables. The endogenous latent variables are dependent variables as they are directly or indirectly affected by the independent variables. So, according to the SEM model, any changes to the endogenous variables can be explained as all the variables are specified in the model. Have a look at the model. We find that there are equations represented, arrows which are pointing, right, and the E which is specifying the error variance from outside also. We find the independent variables or the others, the endogenous variables presented in boxes or in circles or ovals as we may call them. This is a pictogram or pictograph that we use for specifying the structural equation modeling, right. These path diagram as we see in the figure are very important to understand the model that the researcher has developed in the first stage itself while formulating the numerous hypotheses. The next step is the specification of the model structure, that is the formal specification of the model, also called as the measurement model, which tells us the relationships among the latent variables. It is to be noted that the model specification involves extensive literature review and information gathering. The model should specify the latent variables that are not directly observable in addition to the directly observable variables that are supposed to measure the latent variables. So, we have the latent variables and also those variables which have led us to the latent variables in the model structure. In other words, the relationship between the observed and the latent variables is to be defined at the third step of model specification in SEM. The next step is identification of the model structure. The model structure is then identified to check whether the matrices can be solved. That is, whether there is enough information from the empirical data to determine the unknown parameters. The next step is parameter estimation. Every path, correlation and variance in the identified model is called a parameter. The parameter estimation is the next step in SEM, in which the specified and identified model with its paths and variances is subjected to testing. The parameter estimation is carried out with the help of various indices that determine the goodness of fit of the proposed model. Some of these indices are the methods of parameter estimation. The methods of parameter estimation can be unweighted least square. The approach is used when the criteria for normality, skewness and other assumptions about the underlying distribution of variables are not properly met. The weighted least square, this approach is used when assumptions about the underlying distribution of variables are properly met and the sample size is quite large. The maximum likelihood method, this is the most commonly used method of estimation that requires multivariate normality of variables. Test of fitness. The goodness of fit tests tell us how good is the proposed model. The various estimations that check the test of fitness are the chi-square goodness of fit test. As a rule of thumb, for model to be fit, it is expected that chi-square goodness of fit should be non-significant. The normal fit index is the other one. It tests if the model differs from null hypothesis and shows that variables are uncorrelated to each other. The value of normed fit index, that is NFI, ranges between 0 and 1 with higher values indicating a better fit. The goodness of fit index or GFI, the GFI score indicates the amount of variance accounted for in the model. A variant of it termed adjusted goodness of fit index is also used to show the adjusted parametric estimation of the model. Again, its value ranges between 0 and 1 with value of 0.90 and above indicating the acceptance of the proposed model. The next step in application of SEM is evaluation of the results. Now, once you have applied the parameter estimation and check for the goodness of fit, then an ideal condition, the results considered significant if the NFI and the AGFI are above 0.90 and the chi-square goodness of fit is non-significant. However, if the NFI and AGFI are above 0.90 and the chi-square is significant, the sample size needs to be checked. Modification of the model. The modification of model is required to get a better fitness. Some of the statistical indices used to modify and improve the model are the Wall test and the Lagrange multiplier test. The word of caution that needs to be reminded here is that no variable, path or parameter should be deleted or added for the sole purpose of attaining the model fitness. The grounding of the model should always be rested on sound literature and theoretical knowledge only. As strictly mentioned in literature, SEM is a model testing procedure and not a model building procedure. Benefits of using SEM. SEM is a flexible and comprehensive approach that requires a priori specification of model. It is used to test the theoretical hypothesis about the relationships among the variables. SEM is useful to test relationship between the observed as well as unobserved or latent variables. SEM helps to understand the pattern of correlation or covariance among the sets of variables. The methodology is rigorous as it involves simultaneous testing of a set of equations for model fitness. Limitations of SEM. SEM is a confirmatory approach that requires an established theory about the relationships among the variables. A large sample size is required for model specification and estimation in SEM. A minimum of 10 subjects per estimated parameter is proposed to carry out SEM. The technique is also greatly influenced by effect size and the power. So, SEM is not an experimental design that determines cause and effect relationship among the variables. So, these are some of the limitations that one must keep in mind before one goes for the applications of SEM. And some of the major applications of SEM are in causal modeling or path analysis, which hypothesizes causal relationship among the variables and tests the causal models with a linear equation system. Causal models can involve either manifest variables, latent variables or both. Confirmatory factor analysis is an extension of factor analysis in which specific hypotheses about the structure of factor loadings and intercorrelations are tested. Then other application is second order factor analysis, which is a variation of factor analysis in which the correlation matrix of the common factors is itself factor analyzed to provide second order factors. Regression models also use SEM, an extension of linear regression analysis in which regression weights may be constrained to be equal to each other or to be specified numerical values. The covariance structure models, which hypothesize that a covariance matrix has a particular form. For example, you can test the hypothesis that a set of variables all have equal variances with this procedure. The correlation structure models, which hypothesize that a correlation matrix has a particular form. A classic example is the hypothesis that the correlation matrix has a structure of a circumplex. This was proposed by Gutman in 1954, Wiggins, Steger and Gillick 1981. Many different kinds of models fall into each of the above categories. So, structural equation modeling as an enterprise is very difficult to characterize. We will explore the statistical packages for application of SEM here. The SEM is carried out using software programs that are widely available with ample choices. Here we shall discuss some of the commonly used programs and their brief aspects. SEM, being a rapidly evolving and growing technique, needs constant update, and therefore it is advisable to refer to the latest version of the corresponding software program for application. Some of the programs are AMOS. AMOS, or the analysis of moment structure, has two components catering to the graphics, that is AMOS graphics uses diagrams to specify the models, and basic, that is AMOS basic, uses equation statements to specify the models. The program can be accessed at the website addresses mentioned and is quite a popular one to do structural equation modeling. LISREL, or linear structural relationships, is the most popularly used program for SEM. The LISREL has three components: PRELIS, SIMPLIS and LISREL. The software is available on the given website address and the readers can have access to it. EQS provides many general statistical functions catering to descriptive, inferential and multivariate analysis. The non-parametric statistical analysis can also be performed. The researcher can visit the following website for comprehensive information on notable features and functions of EQS. M+. The M+ includes a basic program with 3 modules. The package is useful for analyzing single, multi-level and latent variable models. The website for the program is as given here, and it provides online training also for the users. Besides the popular programs discussed in this section, there are few more like CALIS, covariance analysis and linear structural modeling, Ramona, that is reticular action model, CPATH, that is structural equation modeling and path analysis, which are available. Summary: structural equation modeling is a methodology for representing, estimating and testing a network of relationships between variables, that is measured variables and the latent constructs. The 6-step method of conducting SEM are development of hypothesis, construction of path diagrams, specification of model structure, identification of model structure, parameter estimation, evaluation of the results and modification of the model. The statistical programs for application of structural equation modeling are also introduced to the reader in the text.